Welcome to Omni Eyes. Today we dive into the murky depths to uncover the bizarre vision of the truly incredible platypus. This peculiar mammal from Australia possesses a sensory system so advanced that it totally redefines our understanding of underwater aquatic navigation. While its normal eyes function perfectly well in daylight, they become completely useless once the creature submerges into dark, muddy rivers. To survive in this opaque environment, the platypus closes its eyes, ears, and nose entirely, relying on a completely different mechanism. It hunts by detecting faint electrical signals generated by the muscle contractions of its hidden prey, buried deep within the riverbed. This extraordinary biological ability is known as electroreception, a marvel that allows the platypus to see without actually using physical eyes. Millions of specialized receptors line the surface of its iconic bill, transforming it into a highly sensitive biological antenna for electricity. Whenever a tiny shrimp simply flicks its tail, a microscopic electrical pulse travels through the water directly to the waiting bill. The bill processes these invisible signals instantly, creating a detailed spatial map of the surrounding environment in the brain of predators. This process represents a perfect natural example of multimodal fusion, combining different sensory inputs to navigate through an entirely blind world. Engineers and scientists are studying this exact biological mechanism to develop the next generation of advanced camera sensors for underwater exploration. Traditional optical cameras struggle immensely in murky waters, often returning blurry or completely obscured images that offer no real scientific value. By integrating electromagnetic sensors with standard optical lenses, future cameras could easily peer through dense mud and darkness, like the platypus. This revolutionary technology would allow autonomous underwater vehicles to navigate treacherous environments safely, without relying solely on traditional sonar or light. Imagine a search and rescue drone equipped with this hybrid vision, easily locating submerged objects hidden beneath layers of thick sediment. The platypus proves that relying on a single type of sensor is a massive limitation when exploring the chaotic natural depths. Evolution has equipped this animal with an internal radar system, turning its peculiar snout into the ultimate tool for precise detection. The synchronization between its mechanical touch receptors and electrical sensors allows it to calculate the exact distance of fleeing aquatic prey. When the electrical signal arrives slightly before the physical water ripple, the platypus brain measures the time delay to pinpoint targets. It is a sophisticated biological algorithm, calculating complex physics equations in real time just to secure a simple meal in darkness. This remarkable creature bridges the gap between ancient evolutionary traits and futuristic technological concepts that we are only just grasping today. As we observe the platypus gliding gracefully through the water, we are actually watching a masterclass in advanced sensory integration survival. Every sweep of its bill scans the riverbed like a metal detector, sweeping back and forth to catch hidden electrical anomalies. The dark waters hold no secrets from this relentless hunter, as its internal electrical map illuminates the hidden world with clarity. In the realm of artificial intelligence, multimodal fusion is currently the holy grail for creating machines that can truly understand surroundings. Just as the platypus merges touch and electroreception, our autonomous cars must combine visual cameras, radar, and LiDAR for safe navigation. The natural world has already solved the complex engineering problems that our brightest minds are currently struggling to overcome in laboratories. By mimicking the biological structure of the platypus bill, engineers have created synthetic sensors capable of detecting incredibly weak underwater currents. These artificial receptors could eventually be mounted on submarines, granting them the unprecedented ability to navigate silently without emitting active sonar. The integration of alternative sensors is absolutely crucial for the future of deep-sea exploration, where sunlight simply cannot penetrate depths. We often forget that vision is not just about capturing light. It is about gathering data to construct a reliable model. For the platypus, an electrical field is just as vivid and informative as a brightly lit photograph would be to human. This unique perspective challenges our fundamental definition of sight, proving that nature is incredibly creative when perceiving the vast, complex universe. The muddy bottom of the Australian River is a chaotic landscape, filled with debris, rocks, and tangled roots that obscure everything. Yet the platypus navigates this obstacle course with absolute precision, never bumping into rocks or missing its tiny, agile invertebrate targets. Its brain devotes a massive amount of processing power to interpreting these electrical signals, prioritizing this sense above all others underwater. The visual cortex of this animal is uniquely wired to translate electrical pulses into a spatial map that guides hunting maneuvers. Scientists mapping the platypus brain discovered that the area dedicated to processing bill sensations is significantly larger than any other region. This biological investment proves just how vital electroreception is for the survival of a species living in such challenging aquatic environments. The next time you look at a camera lens, consider how limited it truly is when faced with fog, smoke, darkness. True omnivision requires us to step beyond the visible light spectrum and embrace the hidden energies that constantly flow through reality. Thermal imaging, radio waves, and magnetic fields are the new frontiers of digital perception, heavily inspired by the bizarre natural creatures. The platypus stands as a living testament to the power of sensory diversity, thriving where purely visual predators would face starvation. As the creature surfaces for a brief breath of air, it opens its eyes again, switching seamlessly back to optical vision. This rapid transition between completely different sensory modes highlights the incredible adaptability and processing speed of its highly evolved, specialized brain. It is a living, breathing sensor array, perfectly optimized through millions of years of evolution to dominate its specific ecological niche. When designing the smart cities of tomorrow, we must incorporate the same multimodal philosophy to create truly aware and responsive environments. Security cameras that only record video are quickly becoming obsolete in a world demanding deeper contextual understanding and proactive threat detection. A camera equipped with integrated environmental sensors could detect a chemical leak or an electrical fire long before visible smoke appears. This is the true essence of the Omni's philosophy, seeing beyond the obvious to uncover the hidden truths of reality. The platypus does not just survive in the dark, it thrives, turning a seemingly massive disadvantage into its most powerful weapon. Its prey, completely unaware that their own muscle movements broadcast their exact location, stand absolutely no chance against this silent hunter. The electrical signature of a beating heart is enough to draw the platypus directly to its target with terrifying, flawless accuracy. We are only beginning to unlock the secrets of how these complex biological signals are processed and understood by the animals. Every discovery brings us one step closer to replicating these miraculous abilities in our own machines, robots, and advanced intelligence systems. The fusion of biology and technology is rapidly accelerating, leading to innovations that once belonged exclusively to the realm of fiction. Imagine a future where medical implants can monitor our internal electrical fields, detecting diseases before any physical symptoms ever have chances. This level of internal perception mirrors the platypus hunting technique, using invisible signals to locate hidden anomalies within highly complex environments. The natural world is an infinite library of engineering solutions, waiting patiently for us to read, understand, and apply ancient wisdom. The platypus, often mocked for its strange appearance, is actually one of the most sophisticated and highly specialized predators on Earth. Its existence challenges our assumptions about what is normal, proving that bizarre adaptations often hold the key to incredible evolutionary success. As we push the boundaries of space exploration, we will undoubtedly encounter environments where human eyes are completely useless and blind. Rovers exploring the dark, icy oceans of distant moons will need sensors directly inspired by the platypus to navigate alien waters. They will hunt for the faint electrical signatures of extraterrestrial life, using multimodal fusion to paint a picture of unknown abysses. The connection between a muddy Australian river and the frozen oceans of Europa is a testament to the power of electroreception. Nature has already provided the blueprint. It is now up to our brightest engineers to translate that biological code into reality. The bill of the platypus is a marvel of biological engineering, packed with tens of thousands of microscopic pores called glands. These tiny glands act as electrical conduits, channeling the surrounding water and its hidden energetic secrets directly to sensitive nerve endings. It is a continuous stream of data, flowing effortlessly from the environment into the mind of the animal without conscious effort. Our modern data networks strive for this exact level of seamless integration, attempting to process massive amounts of information in real time. The efficiency of the platypus brain in filtering out background noise and focusing strictly on prey signals is a computational masterpiece. Engineers designing advanced radar systems study this biological filtering process to improve target recognition in highly cluttered and chaotic warfare environments. The ability to ignore irrelevant data is just as important as the ability to detect the actual signal in noisy environments. The platypus ignores the natural electrical background of the Earth, focusing entirely on specific frequencies generated by living, moving aquatic organisms. This selective perception is the ultimate form of biological focus, allowing the predator to strike with deadly precision in absolute darkness. As we develop augmented reality systems, we must learn to manage data overload, presenting only the most relevant information to users. The platypus teaches us that true vision is not about seeing absolutely everything. It is about seeing exactly what matters immediately. This profound lesson in sensory efficiency is reshaping how we design user interfaces and data visualization tools for complex industrial systems. The strange creature from down under has unexpectedly become a guiding light for the future of interface interaction and sensor development. We must protect the delicate freshwater ecosystems that these magnificent animals call home, ensuring they continue to thrive for many generations. Pollution and habitat destruction threaten not only the platypus, but also the invaluable biological secrets that it still holds within DNA. Every time a species is lost, we lose an entire library of evolutionary knowledge that could have sparked the next revolution. Conservation is not just a moral obligation. It is a critical investment in the future of human innovation and scientific discovery. The story of the platypus is a powerful reminder that we are deeply connected to the natural world and its mysteries. By studying the strange and unusual, we often uncover the fundamental principles that govern life, energy, and perception across the universe. The integration of multiple senses allows us to experience the world in all its rich, complex, and deeply interconnected, multidimensional glory. The camera of the future will not just capture a flat image. It will capture the very essence of surrounding environments. It will feel the temperature, sense the magnetic fields, and hear the microscopic vibrations that are completely invisible to human eyes. This omnisensory approach will revolutionize fields ranging from deep-sea exploration and space travel to medical diagnostics and autonomous robotic navigation. The humble platypus, swimming blindly through the mud, has shown us the incredible potential of looking at the world through lenses. It has proven that the darkness is not empty. It is filled with invisible energy waiting to be discovered and understood. As we continue to develop our own artificial sensors, we will always look back to nature for guidance, inspiration, and validation. The biological marvel of electroreception will forever stand as a shining example of how life adapts to overcome impossible environmental challenges. We are entering a new era of perception, where the invisible becomes visible, and the unknown slowly reveals its darkest secrets. The journey of discovery is far from over. In fact, with these new multimodal technologies, our true exploration has just begun. Thank you for joining us on this deep dive into the fascinating world of the platypus and the incredible future sensors. This concludes another episode. Remember to subscribe to Omni Eyes for more incredible insights into the hidden wonders of science today.